Okay, yeah, I've started recording.
Yeah.
So yeah, let me describe the problem. So uh, let's say you have a bunch of variables. I'm defining some variables. Okay. So let's say name is a
Okay.
variable. I'll
Mm-hmm.
say whatever John, right? And then I'll say age is another variable. So these are strings. These variables have string values. Okay.
Okay.
So
Mm-hmm.
okay, and
Yeah.
the value for a variable can reference another variable. So let's say I define a variable called message. I'll say
Yeah.
my name is dollar name, right?
Okay. Mm.
And age is dollar age. So
Okay. Mm.
and in turn, like of course, you might imagine that this is transitive. So I can define like description as another variable. I'll say is so it makes sense, right? So essentially,
Okay. Mm-hmm.
if I wanted to get the value of this variable called description, I would
Mm-hmm.
perform a variable substitution. So I would try to find what the value for message is,
Yeah.
and it will evaluate to this, which in turn will evaluate to whatever these variables are pointing to,
Okay.
right?
Mm.
So I'm giving you a set of these variables with their definition. So you can think of this as a definition for this variable, right? A
Yeah.
definition can reference other variables, and there will have to be necessarily have to be some variables that do not reference any other variables. Otherwise, you'll end up with a loop, right? A cycle. So
Yeah.
now,
Right.
given a set of these variables and their definitions, I want you to
Mm-hmm.
tell me like I need you to answer queries of the following form. Like, given a variable, what is its value, right? So
Okay.
I'll ask what is the value of say message. So and I want you to return the value. So you can think of this as a function that you will implement. Right? I'll give you as a parameter to the function. I'll give you the variable name, and you will return the value.
Okay. Yeah.
Okay. So yeah. So this is what we want to implement here.
Okay. So, in this case, what is the value of message? So, I should be returning my name is John and age is 245, right?
Yes. Yeah.
Okay.
Yeah.
So, yeah, basically we have to replace the value of the variables we
Yeah.
had.
Yeah. And the thing is, you need to these variables, right? If you notice, the variables are surrounded by these dollar signs. So
Mm-hmm.
any string that is surrounded by dollar sign on either side is a variable.
Okay, yeah, got it. So, so the input that will be given is in the string format, right? So,
Yeah, yeah. These
so
are
mine
strings, and
and
any within the string, if there is a sequence of characters that occurs in between two dollar signs, then it
hmm,
is to be considered as a variable.
okay, got it. And a string could contain like what could be the characters in this string. I mean, let's say that John and age
Let's say they're just alphanumeric characters, just
alphanumeric.
A to
Okay,
Z, 0 to 9.
anything can
That's all.
be.
Yeah.
Okay, okay, got it. Yeah.
So yeah,
And
before you begin coding, just spend a couple of
mhm.
minutes thinking about the problem and
Hmm.
how you're going to go about solving it. It's okay to take a couple of minutes in the beginning. Don't rush into coding.
Yeah, sure. I'm
Yeah,
thinking.
yeah. And then we'll discuss the solution, and then if it looks good, then you can go ahead and implement.
Okay, yeah.
Okay.
Okay, the description, my message is message, and we go like this. For the description, the answer will be my message is my name is and then John and age is 245. Like
Yeah,
this
yeah.
is how it is happened. Yeah.
Yes, yeah,
Okay.
yeah.
Yeah. So there is a dependency and My message is message. Answer name is name. If one message is dependent on other, hmm, okay, that is the words like name, age, message, description, are they unique?
Yeah. No to no to variable. You won't have duplicate variable definitions.
Okay, yeah.
There'll only be one. So,
Hmm. Okay, I'm thinking in a way to store it. I'm like I'm thinking it as a graph problem
yeah.
and
Okay.
trying to uh, trying to find how to traverse over the other values when we get some. For example, let's say we have a message. So whenever I find that name, I will uh, I will basically call a DFS. So and basically message will have a link with name and
Yeah.
age,
Yeah.
and this will recursively call, and we can basically decipher all the values that are present in name and ages.
Okay. Okay.
Some kind of link like this. So let me just do it. So for example, we have message. So message will have name as a child element
Correct.
and age as well as a child element, and then
Yes.
we will go into name, and if there are no child elements of name, we will just return the value of name. So that so we will return here John.
Yeah.
And this is how I'm thinking. And as you said, there is no cycle, so
Ah, no, no,
we
no.
should work.
There could be a cycle.
There could be cycle.
Yeah. So you'll have to check for it. So like, yeah,
Okay.
let's assume that there can be a cycle, but you'll have to check for it. Like that doesn't mean so there could be a terminal variable, but you could still have a
Hmm.
cycle in the graph, right?
Okay.
Like name does not depend on any other variable, but you could still have a cycle among, let's say, age, message, and description. They could form a cycle, right?
Okay. So
Yeah.
okay, so you are saying that let's say description has a message variable. So message could also have a description variable.
Yeah. Yeah. Something like that is possible,
That
right? Yeah.
that is possible. Yeah.
Yeah. So you'll have to check for that.
In that case, what will be the output of, let's say,
You
message
can
or
throw an
description?
error. You can throw an error saying this is an invalid set of
Uh,
uh, variables and variable definitions.
okay.
Yeah.
Okay, yeah, got it. Yeah, if it's a cycle, then if it is a cycle, can we use? Hmm, I'm thinking in a DFS manner, but I have doubt that it will it will prevent cycle or what.
So you're saying to get the value for a variable, you will start a DFS from
Mhm.
that node in the graph, right?
Yes, yes.
So can you not just detect the cycle using DFS?
Um, I think I can do it. Yeah, yeah. If we have a element that is already visited and we are encountering that again, I think that be a cycle.
Yeah, you can take an example. Let's say take an example and think through how DFS will work, and
Mhm.
that should make it clearer if you will be able to detect the cycle or not.
Let's say we have message and from message we have description variable at somewhere we are calling. Now yeah, from description, let's say we have a message, and if I find that I'm calling the message again, it will be a cycle. Hmm.
Yeah, that's correct. But try to simulate a DFS from here. Starting, let's say, starting from message.
You mean like write the pseudo code or something?
No, no, no. It just you can like think about how DFS would work uh, when you're doing it right. So
Yeah.
how you would implement it, just think about that, and how will it result in you detecting the cycle.
Hmm. Right.
Yeah,
So if there is a message in description, description goes to again message. So yeah, I think yeah. Uh, One thing I can see that there is a like this is a directed graph. So messages depend on name, age, or let's say description,
yeah,
and description is also depend on message. For example, so in that case, if I am coming back to message, that means it's a cycle.
yeah,
So
yeah.
if I keep the visited node, that will I think serve the purpose. And if I'm visiting the same node again
Yeah.
in and I've found that it is already visited, then this will form a cycle and I can confirm that's a cycle and return.
Okay, okay.
Hmm.
Um,
And
but does visiting the same node twice guarantee that there is a cycle? What if
visiting
there's a diamond like so you can have a directed graph. You can imagine. Okay, let me just give you an example.
hmm.
Let's say uh, let's say A depends on uh, C, which depends on D. Okay,
Good. Hmm.
and then you have A, which also directly depends on D.
Okay, yeah.
So in your DFS, you would visit D twice,
D twice, yeah.
but this is not a cycle, right?
This is not right. Yep.
So how will you handle this?
Yeah, this is not a cycle, but if we visit A, C, D, and we then can visit D. And we are visiting twice. Hmm.
Okay, first think about how DFS, how you're going to implement DFS. Are you going to do iterative DFS or will you do recursive?
I will do recursive.
Okay, so what happens in recursive? How will the recursion work? Let's say take the simple graph of A, C, A, and
Yeah.
D, right?
Mhm.
How will recursion work?
So,
Recursive DFS, how will it work? Let's say starting from A.
so let's say we are starting from A, and we will traverse our all the childs of A, and we will try to visit every child. So
Yes, yeah,
yeah, so I will go like from A to C. Now C will be visited, and all the childs of C will be now traversed. So from C we will go to D, and
So will you mark a node as visited before or after you uh, complete the recursion? That is the thing to be careful about.
yeah. Okay, so in that case, yeah, I got idea. For example, um, whenever I'm visiting the node, I will mark it as visited,
Okay.
and I will go forward
Hmm.
and forward. For example, let's say I came till D, so I marked it as visited.
Yeah.
So when I'm exiting the the recursion of D, I will
Okay.
again mark it unvisited, so
Okay.
that it can be visited again through some different path. This will make sure that if D is being visited in the same path again,
Yeah.
that does not happen. Yeah,
Okay.
so
Yeah.
until and unless we do not come out of the D recursion loop,
Yeah.
the D is in our path. So this will make sure that yeah, this will make sure there is no cycle, or if
Okay.
there is a
Okay.
cycle.
Yeah. 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 That is correct. So let's say you marked A, C, A as visited, and then you made the recursive call to C. You marked C as
Mhm.
visited. You did the same
Yeah,
for D. Now you've
yeah,
come out of the recursion, right? You're coming back to A.
yeah.
Now you'll traverse the other path in the recursion tree, right? You're going to visit D
D.
again.
Yeah. Hmm.
So now at this point, how are you going to conclude whether it is a cycle or not? Because D is marked as visited, and you've come back to the same node again, right?
Yeah, yeah. So I will try to visit it again, because let's say if let's say that yeah, right, right. You are saying it right.
Yeah,
Mm-hmm. Got it. If we are again like we are again visiting D, so generally what would have happened? I would find that okay, um, D is not visited, so I will try to
yeah,
visit it.
yeah.
Hmm.
So you need some way to distinguish whether a node you're visiting is it part of the current uh, recursion call stack or is it outside of the current call stack. You understood my point, right?
Yeah, yeah, right. Hmm.
Yeah. So in the case when you're visiting D the second time, it is not in the current call stack.
Right. Yeah, right. But yeah, for example, when I'm visiting the D second time,
Yeah.
the visited, I will have a visited array, and that will give me the answer, right? For example, the visited array will be
Mhm.
false, so I would know that okay, D is not visited. I have to call it.
But you're marking it as visited every time you're reaching the node, right?
Yeah, but I'm also marking it unvisited when I'm
Oh, okay.
exiting that node.
Okay. So you'll mark it as visited on entering, and then on exiting you'll mark
Yeah,
it as okay.
yeah, right.
Uh,
So it will
okay.
like at every path I will have a list of visited nodes. Or so if I'm visiting it again and I found that it is already being visited right now,
Yeah,
in the same path, so it will form a cycle.
yeah, yeah. That will be. I think that will work. But the problem there is you'll end up visiting the same node multiple times.
Yeah, right.
Is it not? So let's say D had a bunch of other nodes downstream, like E, F. So you'll visit these nodes again the second time you go from A, D, E, F,
Okay, yeah, right.
right? So how when will the DFS terminate then? If none of the nodes are if you're marking all the nodes as unvisited every time,
Mm-hmm.
uh,
Okay, so in this case, the DFS will go till A to F, and then it
yeah,
will again form a
yeah,
path from A, D, E, F,
yeah, yeah,
skipping C. Yeah.
yeah, and then you'll visit D again, then you'll visit E, and then F again. So the entire
Yes.
subgraph behind D will be visited a second time.
Yeah, right.
And you don't really need to do that, right?
Yes.
Yeah,
This will. So, is there any problem like if I visit the same node again? I mean, yeah, there is a repetition, and but it would also prevent the cycle. I'm thinking that way.
what prevent cycle? How?
I mean, if I have visited D and let's say I have visited DEF. So as you said that when I go from A to D and I will again visit DEF. So in that case, yeah, uh, as per my algorithm, I will have to visit DEF again because I'm making D as visited false, and simultaneously E and F are also not visited. So in that case, there will be two times we are visiting DEF unnecessarily.
Yeah. So yeah, basically the idea is you're using a single flag, right? On each node, you're using a single flag,
Hmm.
saying whether it's visited or not. Uh,
Yeah.
in addition to just the visited flag, you need another flag to tell you whether the node you're visiting is it in the current recursion stack or not,
Okay.
right? So the first time you visit D, you will know that okay, this is the first time I'm coming to this node, so it has to be unvisited and it has to be in the current recursion stack. Then you'll mark it as visited, uh,
Yeah.
but but you'll remove it from the recursion stack. You need to maintain another data structure, or you can maintain a per node flag saying whether it's in the recursion stack or not. And every time you exit
Hmm.
it, you will set that flag to false, but visited will remain true because you've visited the node,
Yeah. Right.
right? So you need to
Yeah.
maintain a separate flag. Anyway, so let's since we don't have enough time, what we'll do is you can implement the solution assuming there are no cycles, and then at the end, if we have enough time left, you can modify the solution to also handle cases where could be cycles. That
Okay.
sounds good,
Okay.
right? Yeah. So you can
Yeah. Yeah.
implement. Uh,
Yeah. Yeah.
yeah. So you can implement this as a class maybe, where the constructor takes in these variables and these definitions, and
Mm-hmm.
then another function in the class will allow me to query the value for a
Okay.
variable. Okay? Yeah.
Okay, let's call it solution. And what I want to do here, I want to travel the TFS. Let's not do this. So the input format that I will get, like, will how will that be?
So
I mean,
how do you think, what is an appropriate input format for this? Like if you had to choose something, how would you?
I think map could work with
Yeah,
string
a
and
map,
so
right?
on.
A map of strings to strings. That's
Yeah, yeah, right.
yeah. You can think, you can have your constructor take in a map of variable to its value.
Okay. Let's say I'm taking the unordered map. Does order matters here? I
It
mean,
doesn't matter. So it's fine.
oh,
Ordering doesn't matter here. Right? So
yeah. Let's say variables. And yeah, I think this will be it for the constructor, right?
yeah,
And now what I want to form a graph of this. And okay, what we need to store in this graph? Hmm, I'm thinking to use a adjacency list, and but that will depend on the string format. I mean, something like, and another thing, it can contain the vector of variables. Say list. And when I take a string, I also have to store the original string to form answer. Okay, we have string and we, okay, message, my name is name, age is, so I can give a call to this name variable and age variable as well, and we can do like this. Yeah, I think we do not need this. So, and for query, you are saying to create a new class.
Yes,
Hello, hello.
you said no, no. You can do it in the same class, right? This your solution class can have another method uh, which takes in variable name and returns the value of the variable.
Hmm. So, let's call it query, and DFS variable name. Let's call it a word. Okay, if that is already visited, let's not maintain this. First of all, I'm thinking that I need to pass the string in some way. For example,
Yeah,
a message. Yeah.
yeah.
So, and once I got a dollar sign and like name in the dollar sign, so I will pass that into another DFS function, and I will repeatedly do this and return when I get the answer.
Okay. How are you going to pass the string? Any ideas on?
I'm thinking. So, um, yeah, I think I can do like I can go sequentially. For example, I can go like, okay,
Yeah.
my name is like this, so I will add up the result till this. When I get dollar sign, I will stop
Okay.
and basically try to get the whole symbol, and
Okay.
yeah, when I find the next dollar, I will conclude that the string in the middle is our variable, and I will make
Okay.
a call to that.
There's a simpler way to do it. If you know, there's a split function. You can split a string on a delimiter, right? I think
Yeah,
if you
yeah.
use that, it will simplify it.
Okay. So, but I think that will divide my name is this, and then name in different array,
Yeah.
and I'm not sure about that. But,
So just if I were to split that string on dollar, what would I get?
mhm. Split on dollar. So first, I think you will get my name is then space
Yeah.
this part,
Yeah. So that will be the first
and
element in the array. Second element in the array will be,
yeah, name.
and then third element,
Yeah, third element will be this,
and
and
the
then
fourth
age.
will be this. And then the last
So,
element will be an empty string.
mhm. So in, yeah, I think that would work, and
So how will you get
whatever
the,
string.
yeah, do you see
Yeah.
how you will get the variables out of this array?
Yeah, that I can check in an unordered map if those variables are present in this variable. I mean, in this variable part, if that is present, then I will call it. But if they are not present, that means those are not variables.
No, you can do even better than that. You will know that the uh, even numbered positions are always going to be variables.
Okay.
So the first element is going to be always going to be a non-variable, no matter what. Even if the string begins with $name, right? The
Mhm.
first element in the array is going to be an empty string. Second element is going to be a variable. Third is going to be non-variable. Fourth is going to be variable, and so on and so forth.
Okay, so I can traverse to even positions in that array
Yeah,
which we got from split,
yeah,
and that will serve. Okay,
yeah.
yeah,
You
I
know
can
that
also do
even
that.
numbered. So if you go by zero index, the odd numbered
Hmm, hmm, hmm,
indices
hmm.
are going to be variables. Even numbers are
Yeah,
going
yeah.
to be non-variable. Yeah.
Okay, okay, okay.
So you can use that.
Hmm. Let's call this changes. Yeah. And so word dot split dollar, and sorry, it should be word split dollar, and this will return this string array. Is that will bound? I'm not sure about that declaration, but
Yeah, I think the reason you could have used the autocomplete, but I think the problem is you're using capital S string instead of small s, so that's why
oh,
it's
okay, yeah,
supposed
okay.
to.
Can I include? I think it won't work.
No, this is not there.
Okay, okay, then.
But I think you can include unordered map
Yeah.
vector.
Okay, this is also string. I think I mixed up Java construct here. Look
Yeah,
like.
yeah. So Word does not have a split. Is it?
So how do I apply the split?
Interesting. Yeah, you can look it up, or you can just assume that there is a split. It's fine, even if it's not there. Uh, but it's fine even if you want to look it up online on C++ reference or something. It's also fine.
Okay, let me just check split only.
That's okay. I think we don't have enough a lot of time left, so you can just assume that split exists on the string. You can
Split
use that.
exists on this.
Yeah.
So you mean that
Yeah. Just do word dot split. That's it.
okay. Let's let's say this is true, and what I want, um, let's call it like size. So I'm visiting the array from index 1 and trying to visit in 2 steps.
Okay. Okay.
And then what I will do, I will perform a DFS. Um, let's say this array of I, and this
Yeah.
what will wait let's say that we have message and my name is this, so okay, there's one thing. For answer, I'm forming a result which I will return in the end, and what I can do is result plus equal to, at every call, I will have array of I minus 1, and I will return the result. This could happen till, yeah, I think this will automatically exit when we are done with the conditions.
I think there's a small bug here. What about the last segment, the last element in the array?
What about the last element in the array? So let's say uh, mm, okay, you mean to say the like name equal to John for
No. Line 45. You're looping over this
Mhm.
array, right, in steps of 2.
Yeah.
Uh, and you're adding the previous entry in the array plus the DFS of the current element,
Yeah, right.
right? But what about the last entry in the array? There is no variable after that, right? So
Yeah.
as an example, let's say I have uh, this is dollar $XYZ dollar. Yeah, let's say this is my variable.
Hmm.
So first you will go to XYZ, you will do DFS on XYZ, you will get the
Yeah.
value, and to
Yeah.
result, you will add this is and whatever
Yeah.
the value of XYZ is.
Mm-hmm.
But then who will add this?
Okay. Okay, for odd cases, yeah.
your result will be missing this string, right? Variable.
Uh, so I can just have a check if the length of the array is odd, then I will add the last element as well.
No, the array will always be even length. It won't be odd, right?
Okay, but
Is that correct? Wait 1 second. Oh
if
no,
this is
that's
odd,
wrong.
right?
That's wrong. Yeah, scratch that. Scratch that. Yeah. Yeah. You're saying the array is,
If the array is odd length, then I
yeah.
would know I am not visiting the last element. So to compensate, I am
Okay.
putting a condition. If array is odd,
Uh,
then I will add the last result.
okay. Yeah, that will do it. Or as I think a simpler approach would have been just iterate over the array, and
Hmm.
if it is even numbered, if the index is even, then you just add the current value to result. If it is odd, you add DFS of that value to the result, right?
Okay,
That's simpler.
yeah, that is also fine. So in that case, if I mod 2 equal to 0, then it's even, and in that case I will do array of I, else I will, yeah, yeah, if it is odd, then we will do DFS. Okay, and mm,
Yeah,
and one more thing is there when I'm doing DFS.
yeah.
Think for example, if we have a message, so I will do my name is, and then I will do a DFS for the name variable, and
Yeah.
the age variable as well. So what is the value of age? How will we basically, yeah, so yeah, I think we need yeah, we already have actually. So what, this is the word, and yeah, so basically whenever I'm calling the DFS, I will
Yeah.
passing the word,
Yeah.
but I need its value when I'm doing the split. So
Yes.
in that case, I will call messages of this. So sorry, yeah, so this will give fetch me the value of that
Yeah. Yeah.
variable,
Yeah.
and then apply the split. And
That is correct.
this
Yeah.
one, uh, just for error handling, let's say that if I found that this word does not exist
Yeah.
in the, then I maybe return the empty string.
Or you can throw, and this will never happen if the input is correct. If this happens, then that means there's something wrong with the input. So you can even throw an exception. It would be better to
Okay,
throw an exception.
yeah, right.
Yeah, like
Let's,
invalid variable name or something like that. Okay, so yeah, apart from this, what do you think is a drawback of what you've implemented here? Do you see any obvious things that are missing in your DFS? I think it
okay,
is correct. Like it is correct, but there's something missing.
is something missing. Okay, I have used all the variables and the split is right and array size DFS.
Like think about in terms of performance. Like how many times is he going to each DFS call uh,
Yeah, right.
going to be made on each word?
Uh, yes. I can store the result somewhere for particular variable. Let's say
Yeah,
if we have already visited that variable, then we can store that value. And whenever we find that we have already visited that, and we have basically we are caching that result.
yeah. You need to cache it. Otherwise, you'll end up calling the same word multiple
Same. Yeah.
times. Yeah, again
Yeah.
and again.
Right. Right.
So how would you do that?
And
Where would you do that?
okay. Let's say I am making a DP kind of map to store
Okay.
the result.
Yeah.
And what will I do in the end? For every word I will catch this result, and here I will put a condition. If I find this word
Hmm.
in the DP map, then I could return from there only.
Yeah.
So I think this will do it.
Yeah. Yeah. So this so you've implemented this DFS function, right? Where will
Hmm.
you call it?
Yeah, whenever there is a query, then it will be
Oh, you
called.
just call it here. Oh, yeah. Right down. Okay. Yeah. So you will call it. So the only thing missing here is cycle detection,
Yeah, right.
right? And we discussed that earlier, but I don't think we have enough time to do that.
Hmm.
But yeah, you can go ahead and like just for practice, you can modify the solution later after the interview, also just to
Yeah, sure.
see how we'll do
Sure.
that. But yeah, so we'll stop here. So yeah, any questions for me? Like, or should I stop recording? But no, we'll keep
Yeah,
recording until we discuss the whole thing. Yeah,
I think just we can discuss the feedback and maybe.
yeah. Okay, okay. So I think you started off well. Like asked some good clarifying questions. Try
Hmm.
to understand understand the problem well, and then we discussed some approaches. All that went fine. The part where I think you could have done better was the DFS. Like I think you need to revise how DFS works, how cycle detection works. So the thing is, in these interviews, you barely have
Hmm.
any time to think, right?
Yeah, right.
They will just give you a problem and expect you to start coding right away. I mean, you don't have time to reason about how DFS works, how to do cycle detection in directed graph versus undirected graph. All these things you should
Hmm.
know beforehand.
Yeah, right.
So it's a good idea to revise all these common algorithms, like all the basic data structures, cover all the basic algorithms like BFS and DFS. You should know very well because
Hmm.
like almost in every interview round, there'll be at least one interview where they'll ask you something related to BFS, DFS. So that you should know very well. So you could have done better there. We spent a lot of time discussing how cycle detection will work, right? So
Yeah,
uh,
right.
if you had if you had already known that, we could have saved that time and you could have completed the implementation right fully.
Yeah, sure. Yeah, right. Yeah, I'm comfortable with DFS, I think, but yeah,
Yeah,
cycle detection was a
yeah.
tricky part.
Yeah. So just go through. There are a lot of these sites which cover these basic algorithms, right? I think
Hmm. No.
I think Interview Bit is one like that has got a good set of problems that cover all these concepts, like problems. So yeah, covering all that as well. Like code wise, I think your code was fine. I didn't find any like obvious issues with it. Um,
Okay.
uh, yeah. So then, except for this part, maybe like where you were this part where you were parsing the string,
Hmm. Hmm.
right? You were trying to. So when I pointed out that your solution does not handle this edge case,
Yeah.
you tried to add it on towards the end, right? Checking whether the array size is odd or even.
Mm-hmm.
So at such points, I think it's better to just spend some time thinking about what's the best approach. So this turned out to be the easier way to code it, right? You just check whether the index is odd or even, and then add the value to the result.
Yeah, right,
So
right.
yeah, interviewers always look for such kinds of solutions where you don't end up overcomplicating it. So
Mm-hmm.
yeah, so it's okay to take. So whenever the interviewer points out something that's wrong with your solution, or some edge case that you've missed, instead of just trying to modify whatever you've written just to fit that case, it's better to take a step back and think about
Think, yeah.
what's the best way to solve it. Other than that, it's fine. I think you did well.
Okay.
Yeah. So
And that cycle detection, like,
yeah.
is there any other solution to do this, or
No, this is a standard problem, right? The cycle in a directed graph.
hmm.
You have to, I think you have to maintain visited, and you have to maintain a stack. I think a separate stack of nodes that you've seen.
Okay, yeah.
Yeah, you can look it up. It's a fairly standard
Okay.
problem. So just
Sure, sure.
yeah, think about all these common problems. BFS and DFS. There's lots of things that can be done using this that.
Sure, sure,
So yeah,
yeah. Mm-hmm.
lots of interviews ask these kinds of problems. So it's better to be fully
Prepared, yeah.
prepared. Yeah, because I was
Yeah.
asked this exact same problem. I was asked in one of the interviews. So and I didn't even I didn't know. I had not practiced cycle detection, so I spent a lot of time thinking about, just like you did. Right? I spent a lot of time thinking about how it will work and
Yeah,
how to
right.
implement it.
Yeah.
Yeah, so it becomes
Mm-hmm.
stressful in during an interview when you're not able to understand. So if you know these basic problems, you don't even have to think about it. You'll directly know the way to do it, and you can focus on the remaining parts of the problem, coding it well, uh,
Yeah.
and that way you'll have a much better chance of doing really well.
Yeah, right. I also felt that it impacts your performance as well
Yeah,
in
yeah.
the.
So it happens to me as well. Like, so a lot of times, the first 15-20 minutes, I'll just be thinking, I would not have written a single line of code, and then it becomes really bad. You don't have
Daily basis.
a
Yeah,
lot of
yeah.
time. So
Mm-hmm.
within 5 to 10 minutes, after the problem has been given, you should have at least some clear idea of how you're going to implement it, and then you should start coding. Um,
Yeah, right.
because they're always looking for coding signals. Like you can't just talk in a coding interview, right? You have to write code,
Mm-hmm.
and they give you barely any time. Like basically, you get 40 minutes maybe for 40 minutes to write code, and yeah. So you just keep practicing, and
Yeah,
you'll get
sure.
it. Yeah.
Yeah.
Okay. So yeah, I'll stop recording. Uh,
Okay.